नमस्कार विद्यार्थी मित्रांनो. In series of 5 lectures, we have completed the chapter that is the matrix. Today, now we are going to start with the new chapter that is the pair of straight lines. We know that in 11th standard we have seen the introductory part of the pair of straight line. There is a one chapter that is the straight line, and in straight line we have completed the different properties of the straight line, like what is mean by inclination. What is inclination? We know that the inclination is an angle made by the line with the positive direction of x-axis. Suppose that this is the line L, okay, and it makes an angle theta with the positive direction of x-axis. Then this theta is called as the inclination. Okay, then this theta is called as the inclination. If theta is the inclination, then tan of theta is called as the slope and it is denoted by m. Okay, and we know that the two lines having same slope. Suppose that there are two lines m1 and m2 having slope m1 and m2. They have the same slope, that is m1 is equal to m2 if and only if lines L1 and L2 are parallel to each other. Also we know that the lines are perpendicular, then the product of their slope, that is m1 into m2, is equal to -1. If the lines are perpendicular to each other, then m1 into m2 is equal to -1. That means if the product of the slope of the two lines is -1, then the lines are perpendicular to each other. Lines are perpendicular to each other. That is, L1 is perpendicular to the L2. Also, we see the slope of the line parallel to the x-axis is 0. Slope of the line parallel to the y-axis is not defined, and etc. In second point, we have seen the different equation of the lines, that is slope point form, slope intercept form, 2-point form, normal form, double intercept form, etc. Again, in third point, we have find the general equation of the lines, and we know that the general equation of the straight line is a linear equation in x and y, that is x plus by plus c is equal to 0, and we say that the every linear equation in x and y always represent a straight line, because the graph of this type of equation in x and y always a straight line. Therefore, the every linear equation in x and y always represent a straight line. Also, we find the slope of this line, that is the m is equal to minus a upon b. Okay. In third point, last point, we combine the such two lines, such type of the two lines, that is a1 x plus b1 y plus c1 is equal to 0, and this is this u, and v is the line a2x plus b2y plus c2 is equal to 0. Then the equation of the line passing through the point of intersection of these two lines, that is u is equal to 0 and v is equal to 0, is given by u plus kv is equal to 0. U plus kv is equal to 0, and this is called as the family of lines, equation of the family of lines. Okay. Also, we seen the angle between these two lines. If the lines like a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, having the slope say m1 and it having the slope m2. Then the angle between these two lines is given by tan of theta is equal to m1 minus m2 divided by 1 plus m1 into m2. All these properties of the straight lines we are completed in 11th standard. Today we are going to start with the pair of straight lines. So in pair of straight line, the first point is combine the equation of the line. Combine the equation of the line. So which equation is called as the combined equation of the line? An equation which represent two lines. An equation which represent a true line, two lines, is called as the combined equation of these two lines. जेव्हा एखादं इक्वेशन दोन वेगवेगळ्या सेपरेट लाईन दाखवल त्यावेळेस त्या प्रकारच्या इक्वेशनला कंबाइंड इक्वेशन किंवा पेयर ऑफ स्ट्रेट लाईन असं म्हणतो आपण. तर आज काय म्हणतो आपण? पेयर ऑफ स्ट्रेट लाईन्स. मग समजा लेट असं गृहीत धरूया, लेट u is equal to the line a1x plus b1y plus c1 is equal to 0 and v is the line a2x plus b2y plus c2 is equal to 0. Then the combined equation of these two lines, we know that the family of lines, the equation of the line passing through the point of intersection of these two lines, या दोन लाईनच्या पॉइंट ऑफ इंटरसेक्शन मधून जाणाऱ्या लाईनचं हे इक्वेशन आहे. याला आपण फॅमिली ऑफ इक्वेशन ऑफ लाईन असं म्हणतो. तर आपल्याला कंबाइंड करायचे आहेत, या दोन लाईन आपल्याला एकत्र करायच्या आहेत. देअरफॉर द कंबाइंड इक्वेशन ऑफ these two lines is given by u into v is equal to 0. That is a1x plus b1y plus c1 into a2x plus b2y plus c2 and this is equal to 0. This is the combined equation of the lines. That is u into v is equal to 0. Okay. Now question arises that whether this equation represent a combined equation, every such type of equation represent a combined equation or not. The theorem says that every such type of equation, that is u into v is equal to 0, always represent a combined equation of the lines, that is the pair of straight lines. So the theorem is okay. Theorem is an equation u into v is equal to 0 represent combined equation of two lines u is equal to 0 and v is equal to 0. Now we have to prove that this equation represent a combined equation of the two lines u is equal to 0 and v is equal to 0. How to prove this? We have to prove that we have to consider any one of the point on the line u, and this point also satisfies this equation. And also we have to consider any one of the point on the line this v is equal to 0 and show that this point lies on this line. That means this equation must be satisfied that point. Or in other hands, we have to consider any one of the point on this line u into v is equal to 0 and we have to prove that this point lies on this line also and this line also. म्हणजे काय करायचं आहे आपल्याला, तर u वरचा कोणताही एक पॉइंट घेतला तर तो या लाईन ही लाईन सॅटिस्फाय करते, हे इक्वेशन सॅटिस्फाय करते हे दाखवायचं आहे. आणि v वरचा कोणताही एक पॉइंट घेतला तर हे इक्वेशन सॅटिस्फाय करते हे दाखवायचं आहे. त्याचबरोबर या लाईनवरचा कोणताही एखादा पॉईंट घेतला तर तो पॉईंट या लाईनवरही असतो आणि याही लाईनवर असतो, म्हणजे हे इक्वेशन सॅटिस्फाय होत आहे आणि हे पण इक्वेशन सॅटिस्फाय होत आहे, हे आपल्याला प्रूव्ह करायचं आहे. ओके, मग प्रूफ मध्ये ओके प्रूफ मध्ये लेट u is the line a1x plus b1y plus c1 is equal to 0 and p is the line a2x plus b2y plus c2 is equal to 0. Then the combined equation of this line is the combined equation is u into v is equal to 0, that is a1x plus b1y plus c1 into a2x plus b2y plus c2 is equal to 0. Okay, we say that this is equation number 1, this is equation number 1. Let px1 comma y1 be any point on the line u is equal to 0. समजा px1 y1 हा कोणताही एक पॉइंट या u is equal to 0 वर आहे. वरला एक कोणताही एक पॉइंट कन्सिडर केला तर जर हा पॉइंट px1 y1 हा u या लाईन वरचा असेल तर त्याने u या लाईनचं इक्वेशन काय केलं पाहिजे, सॅटिस्फाय केलं पाहिजे. देअरफॉर a1 x1 plus b1 y1 plus c1 is equal to 0. This is equation number 2. Okay, now we have to prove that this point p x1 y1 also satisfies this equation, that is u into v is equal to 0, that is a1x plus b1, that is this equation must be satisfied. Okay, now we consider the LHS of this line. Okay, this equation from equation 1, we say that from equation 1, equation 1 वरून this line, we have to prove that this point lies on this line. Okay, so LHS is equal to a1 x1 plus b1 y1 plus c1 into a2 x1 plus b2 y1 plus c2. Okay, and we know that from equation 2 a1 x1 plus b1 y1 plus c1 is equal to 0. So this is a1 x1 plus b1 y1 plus c1 is equal to 0. So this is 0 into a2x plus b2y x1 plus b2y1 plus c2, and this is equal to 0. 0 into something is 0. So this is the RHS. This is RHS. That means this point px1 y1 lies on this line, that u into v is equal to 0. Similarly, that is px1 y1 also lies on the line uv is equal to 0. Similarly, we can prove any point on the line v is equal to 0 also lies on the line u into v is equal to 0. u v is equal to 0. म्हणजे आपण अशाच पद्धतीने v वरचा एक पॉइंट घ्या, तो v चं इक्वेशन सॅटिस्फाय कर, म्हणजे हे v चं इक्वेशन सॅटिस्फाय करत, तो पुन्हा तो पॉईंट जर याच्यावर घ्यायचा असेल पुन्हा LHS घ्या, पुन्हा याच्यामध्ये पुट करा, देन V इज इक्वल टू 0 येईल, देन 0 into something is 0. So in this way we can prove phi also. Now let us consider, let P x dash comma y dash be any point on the u into v is equal to 0. समजा p x dash comma y dash हा पॉइंट u into v is equal to 0 वरचा कोणताही मी गृहीत धरला, तर तो जर पॉइंट या u into v is equal to 0 वर जर असेल तर त्यांनी हे इक्वेशन काय केलं पाहिजे, सॅटिस्फाय केलं पाहिजे. therefore a1 x dash plus b1 y dash plus c1 into a2 x dash plus b2 y dash plus c2, and this is equal to 0. We know that the product of the two number is 0 if and only if any one of the number must be 0. दोन संख्येचा गुणाकार 0 कधी असतो, तर त्यापैकी कोणती तरी एक संख्या काय असली पाहिजे, 0 असली पाहिजे. म्हणून therefore a1 x dash plus b1 y dash plus c1 is equal to 0, or a2 x dash plus b2 y dash plus c2 is equal to 0. That means this is the line u, right? This is u is equal to 0 and this is v is equal to 0. So these points lies on the u and v also. This point also satisfies this equation u and v. Therefore we say that an equation u is equal to 0 represent a combined equation of the line. Therefore the equation an equation u is equal to 0, u into v is equal to 0 represent combined equation of line. Okay, combined equation of the straight line. So we prove that the combined equation of the line, that is u into v is equal to 0, is always a combined two, always represent a two straight line. Okay. Now we have one of the remarks. So remark says that this equation u into v is equal to 0 is called as the combined equation of the two lines u is equal to 0 and v is equal to 0. This is also called as the pair of straight lines of the two lines u is equal to 0 and v is equal to 0. The remarks is understand? Remark समजला का? याच हे जर इक्वेशन कंबाइंड इक्वेशन या दोन लाईनचं असेल तर यालाच आपण काय म्हणतो, पेअर ऑफ स्ट्रेट लाईनचं इक्वेशन असं म्हणतो. यालाच काय म्हणतो आपण, पेअर ऑफ स्ट्रेट लाईन. कंबाइंड इक्वेशन इज ऑल्सो कॉल्ड एज द पेअर ऑफ स्ट्रेट लाईन. ओके. Now we solve some examples. Okay. The first example is find the combined equation of, write down the equation, find the combined equation of the pair of lines first is 2x plus y is equal to 0 and 3x minus y is equal to 0. आता सोल्युशन मध्ये बघा, आपल्याला याचं कंबाईन इक्वेशन तयार करायचे फक्त. मग सोल्युशन मध्ये लेट u is equal to this line 2x plus y is equal to 0 and phi is equal to this line, that is 3x minus y is equal to 0. We have the combined equation. Combined equation तुम्हाला माहित आहे काय? combined equation u into v is equal to 0. Therefore this u into v is equal to 0. Okay, put the value of u, that is 2x plus y into 3x minus y, and this is equal to 0. So take the multiplication of these two bracket. या दोन कंसाचा गुणाकार घ्या. 3 2 ला मल्टिप्लाय केला, that is 6x square. 3 into y is 3xy. minus y ने मल्टिप्लाय करा, minus 2xy, and that is minus y square, and this is equal to 0. So this is 6x square plus 3 this is plus 3xy minus 2xy, that is xy only, minus y square, and this is equal to 0. This is the pair of straight line, equation of the pair of straight line represented by the two lines. 2x plus y is equal to 0 and 3x minus y is equal to 0, or it is also called as the combined equation of these two lines. Now next question is, find the combined equation of pair of lines passing through the 2, 3. Now find the combined equation of the pair of lines. Second question is, lines passing through the point, passing through the point 2, 3 and parallel to the coordinate axis, and parallel to the coordinate axis. Okay, and parallel to the coordinate axis. Now we solve this problem. Okay, आपल्याला अशा प्रकारच्या दोन लाईनचं कंबाईन इक्वेशन तयार करायचं आहे की त्या दोन लाईन 2,3 या पॉइंट मधून गेल्या पाहिजेत आणि त्या दोन्ही लाईन कोऑर्डिनेट ऍक्सिसला पॅरलल असलेल्या पाहिजेत. त्यापैकी पहिल्या प्रॉब्लेम मध्ये आपल्याला लाईन दिल्या होत्या, आपण डायरेक्टली त्याचा त्या u into v मध्ये पुट केल्या आणि त्याचं इक्वेशन तयार केलं. But in this problem we have to find out these lines and then we have to combine these two lines. म्हणजे या प्रॉब्लेम मध्ये आपल्याला त्या दोन लाईन शोधायच्या आणि नंतर त्यांना कंबाईन करायचं, म्हणजे त्यांचं कंबाईन इक्वेशन फाइंड करायचं आहे. मग थोडं जर क्वेश्चन कडे तुम्ही पाहिलं तर त्या दोन लाईन या बिंदू मधून गेलेल्या आहेत आणि या कोऑर्डिनेट ऍक्सिसला काय येतात, पॅरलल आहेत. मग तुम्हाला माहित आहे की दोन बिंदू मधून एका बिंदू मधून जाणारे, बघा समजा हा 1 2 3 4, this is 1 2 3 4 and 5 etc. Okay, this is x axis, this is y axis. Now the lines are, the point is 2, 3. So this is the point, say 2, 3. So the lines are passing parallel to like this. One of the line is parallel to the x-axis and other is parallel to the y-axis. Okay. So we know that the equation of the lines parallel to the x-axis is given by y is equal to k. So solution then we have the equation of line parallel to the x-axis is, x-axis ला पॅरलल असणाऱ्या लाईनचे इक्वेशन असतं काय असतं, y is equal to k. तर इथं k ची किंमत किती आहे, 3 आहे, म्हणून y is equal to 3 means the equation is y minus 3 is equal to 0. The we have the equation of the line parallel to the x-axis and and passing through the point passing through the point 2 comma 3 is y is equal to 3. Therefore y is minus 3 is equal to 0. This is the equation number 1. Now secondly, we have the equation of the line parallel to the y-axis is x is equal to k. म्हणजे वाय ॲक्सिसला समांतर असणाऱ्या रेषेचे इक्वेशन काय असतं, x इज इक्वल टू के. हे आपण 11वी मध्ये पाहिलेलं आहे. मग इथं के ची किंमत किती आहे, तर इथं के ची किंमत 2 आहे, कारण ही लाईन या 2 या पॉइंट मधून अशी पास झालेली आहे. 0,2 मधून पास झालेली आहे, म्हणून सॉरी 2,0 मधून पास झालेली आहे. म्हणून we have also the equation of line parallel to y-axis and passing through 2 comma 3 is x is equal to 2. This implies that x minus 2 is equal to 0. This is equation number 2. Now the combined equation of the line is the combined equation is that is y minus 3 into x minus 2 and this is equal to 0. या दोघांचं कंबाईंड इक्वेशन 1 आणि इक्वेशन 2 चं कंबाईंड इक्वेशन. ओके, ही लाईन कोणाला पॅरलल आहे, एक्स ॲक्सिसला पॅरलल आहे, ही लाईन वाय ॲक्सिसला पॅरलल आहे. मग दोन्ही लाईनचं आपल्याला कंबाईंड इक्वेशन तयार करायचं आहे. मग काय कंबाईंड इक्वेशन, तर x इंटू वाय, एक्स ने वाय मायनस 3x, मायनस 2 ने मल्टिप्लाय करा आहे मायनस 2y आणि मायनस मायनस प्लस 3 दुने 6 that is 6. So this is equal to this is the required equation, combined equation of the lines which are parallel passing through the point 2 comma 3 and parallel to the coordinate axis. अशा पद्धतीने आपण combined equation of the lines वेगवेगळ्या पद्धतीने फाइंड करू शकतो. ओके, so we stop here.